Yeah, so I want to talk to you about user change modeling and graph applications today. And let me maybe start with some words about questions. So please put as many questions as you want in the comments. And I hope I'll be able to get to them after my talk. There will be also colleagues of mine joining in the chat, so they will probably also be able to answer some of the questions already in the chat. So let me get started. So I'm a digital engineering specialist working at RLE International. And this is where I came across this topic, and I want to present what we've been doing in our team for the last year, basically. So first of all, I'm going to give you a small background as to why we're looking into that problem at all. Then I'm going to present to you the modeling challenge that we're in front of, give you some solutions that we thought of, and then at the end have a discussion about whether the solutions are good and which one is maybe the best to use in which case. So let me start with giving you some background. Just a quick big business background. So as I said, I'm working at RLE International, which is an internationally acting engineering services provider and working in the automotive industry. It has already a long history, so it's 35 plus years old. And we have experience with a wide range of customers on the one hand, and of course also a wide range of products and programs and companies. So there's a lot of knowledge in the heads of our employees, and this is what we're working with. If you want to know more about the background to the work that I really do, there's also a NODES2020 talk that you can look into if you want to. So we have a very specific aim. We want to digitalize, of course, every company wants that. And what we want to achieve is to create innovative consulting software products that basically contain the company's knowledge about the products, programs, the companies, and the industry standards. And what we want to provide to our customers is a significantly shorter concept phase of an automotive project. So what you can imagine is that the first phase of where a company decides which car to build, especially a startup, which car to build next, and in which markets to go into, which features to use, is a very long phase because you need to think about many factors. And you need to make a lot of decisions, and the decisions impact other decisions and so on. So this is a very complicated phase, which can last up to 2 years normally. And what we want to do is we want to provide help, so consultancy in that space, and also replicable and reliable solutions, because often when startups seek consultancy, then the solutions they get there are very reliant on the person they're talking to, on the consultants themselves. And what we want to get here is replicable and reliable solutions that do not depend on these individuals. And we want to obtain that by taking this knowledge that we have in the company with projects like this before and putting that into a graph application where the complete knowledge is available and which can then be queried for new customers to get insights into what they could do and which decisions are reasonable or which aren't, and which are the impacts of their decisions. And how we do that is that we basically want to put everything together. We have a holistic vision. So there's a customer input, which is basically a company telling us that they want to build a certain car, they want to go into certain markets, they want to achieve certain goals like return on invest or whatever. And us taking this information, running that through the knowledge graph that we have built from our company's knowledge, and then basically to suggest solutions, suggest features, suggest things to do, things not to do, and also then a projection basically into the future. So if you do this, then you will obtain that. And what we want to have is some kind of concept modeler. So this modeler provides real-time responses. So the run through the graph is very quick, gives a solution suggestion to the customer, and the customer can then see whether he likes that solution or basically tune parameters. Well, I don't like this, I don't like that, so I'm going to change that and see what kind of impact that has. Normally, this kind of process takes a lot of time. So basically like 2, 3, 4 to 6 months if these things are done iteratively in person. So people say, okay, maybe I should do that. And then there's a whole analysis of what this decision impacts. And then turning these circles here takes a lot of time. And we want to really have that shortened. And then once the customer agrees with the solution that we suggest, they can go into the execution. And as I said, hopefully this shortens their concept phase from 2 years to maybe a month or 2. But if you look at this problem now, this has a very specific requirement for any application that we build in this software tool set that we want to have. The requirement is that the customer comes in, gives some input in the user interface, and receives some solution, which should be a best initial solution. And as I said, well, this runs through the knowledge graph that we have behind. So the knowledge graph is modified to the inputs that the user gives. It's provided to the customer. Of course, they don't know it's a graph behind, but they get a solution for their inputs. And then they're going to adapt that. So they're going to say, well, I don't like this, I don't like that, I want this changed. There's some other parameters I want to try out, maybe game a bit with all this concept stuff. And so, yeah, so there's a requirement for providing an initial solution, but also for having the possibility for the user to adapt whatever he needs for this project. Let me leave that as a business background, and now let's go into the details of the graph. So what we have, as I said before, is we want to store knowledge. So we want to gather the knowledge of our company and put that into a graph. So we have a core data storage where we store the knowledge. Now, if a user opens the application, he provides some input. So he tells us about his car project, his aims for the project. And what we provide him then is a already personalized subgraph, basically. So he provides inputs, and we run some calculations in the background and provide him the answers to his inputs. And what we do here is, so we basically copy the graph, and we're probably going to use some multi-database features of Neo4j to do that. We provide a personal database or graph in this case to the user, which contains the personalized data. And this is depicted here with the pink. So this is the same nodes, but already with different properties on them. And of course, if there's a second user, then he also can provide other input and will also obtain his own personal knowledge graph where he can gain insights from. But this will be, of course, already different from the first user's input, first user's graph. Now, as I said, the user will definitely customize things. So the first initial solution that we gave will never be the one that the user will go with. So he will change things. So maybe he'll change some properties on nodes. And he also wants to know what's happening. So what I'm presenting here is basically the user interface view on things. So he wants to know what he did and what kind of implications these changes had. And this also includes node deletions. So he can also delete nodes, or of course, again, he doesn't know that it's a graph, but he can delete things. What we then want to have from the application is that he can undo changes. So basically, he can go to any change that he has done and say, well, actually, I want to try out without that change. And this undoing should also be possible for node deletions. And the interesting part about this is that we don't want to revert to a certain change set. So he doesn't have to undo his last change, but he can basically undo any change. What we found out when discussing things is that there might be changes that are dependent on other changes. So you can't undo any change, but mostly you should be able to go to any place and see what you can undo. What the user then always will do is save a project. So he has fiddled around with the graph that we presented to him, and this whole thing, this deciding on the concept for a project will of course not be done in 10 minutes or half an hour. So the user needs to be able to save his project away, come back later, next day, next week, next month, and look at their graph again. So we somehow need to take all these changes of the user and store this somewhere permanent. So what we're doing is we will have user databases which are fluent, so they will be freed up again, and we need to save away the changes somehow. And then there's something interesting which we also need to consider. This knowledge graph that we have will always grow. So there's the automotive industry, and no other industry is standing still. There's always more knowledge, more possibilities, other ways of manufacturing, whatever. So the knowledge will always grow. And what if now a user has done a project in our tool and has conceived some project of some data, and now things change. So of course he wants to be informed about new changes. Maybe the project that he did yesterday is now changed because things have changed, and he wants to know about this. So when the user now loads his project back, he should also see the changes in the graph. So he should not only see the things that he has changed before, but his original changes somehow have to be merged with the new things that the knowledge graph knows about. And this is the modeling challenge that I'm in front of. So there's a lot of things that are a bit different, I think, to things that are normally done in graph databases. So normally you see a lot of querying the graph and reading from the graph, like if you want to do fraud detection or patient journeys, or if you want to look at COVID graphs. So you use the graph to look at things, and maybe you run some machine learning algorithms to even calculate some things from the graph. But here we really have the requirement to take the user actions into account and model them in the graph and save them away, and also deal with this growing knowledge graph. And that brings me to the aim of our project, or of this talk as well. So we need to find a modeling solution to this challenge that results in, first, the customized graph being visible with all the modifications. So basically we want to see the modifications on the nodes and not just have them somewhere for the front end and the developer to be able to work with the application. So we want a clean user graph. Then we need the saved away project to be loadable in an acceptable time frame, and also to be savable in an acceptable time frame. This is also a challenge, as we perceived. Then, as I just said, we also need to have this grown knowledge graph merging. That means if the knowledge graph grows and the user reloads a project that he has done before, he needs to take into account all these changes that have happened to the knowledge graph. Also, we need this log functionality, as I showed, where the user sees which changes he has done, and also these changes need to be undoable in a clean fashion. So how do you undo the changes within the graph in the backend so that you don't start fiddling around badly with the graph? And with these 5 aims in mind, let's now look at some solutions that we found over time. So all the examples that I want to give now start from this process knowledge graph. So basically we just have a simple graph which contains some activities and some edges between the activities, a start and an end. And now the user changes things in this graph. And I want to show how you could go about modeling these user actions. So let's look at the first idea how you could do that. And let me take that in front. So this is a very weak idea, and also you have to combine this with others to make it really reasonable. So the user comes and changes maybe just the duration of this activity to be 10. So this is just one property that he changes on the node. Maybe he changes his mind and changes the duration to 20. So that's the 2 actions that we want to look at throughout all these examples. So what you could do, well, you just write the changes onto the activity node. Okay, you do that. And if you want to save away this change of the user, you just take a screenshot of the graph. So basically, you just take this whole graph with all the changes that the user has done and save it away somewhere. So there you have several possible solutions. So first of all, you could just take this graph from the user database, just copy it, put it into your core database with some tag that this belongs to a certain user or project. And then you have a second graph in your core database. This, of course, sounds already quite fishy. Then, of course, your graph will grow enormously and you will have a lot of duplicate information in that graph. What you could also do is you just save away this graph with a GraphML file or a GraphML string. So there's a functionality in Neo4j that you can just export a graph as a GraphML, and you could save that away either on some node in the core database, or maybe in some SQL database, or in a file that you store somewhere. So there's a lot of possibilities. What you could also do is you could use a cipher create statement. So there's also functionality that Neo4j provides, where you just take the graph and export it as a cipher. And then basically what you get is a string, or again, a file where there are all the create statements to recreate the graph with all the properties and all the edges and so on. Again, you can store this in a SQL database, in a file structure, or somewhere else. If you want to load the graph, all you have to do is, of course, retrieve it again. So either from the core database, or from a file, or from a string, or from anywhere, and just put it back into the user database. Creating a log, well, this is where I say this solution needs to be combined with one of the next solutions. So if you just put the action onto the node itself and don't save away any timestamp or anything, then of course you won't be able to create a log from that. And you can also not really analyze what the user did before. Let's look at the second solution that you could think of. This is the action on node solution. So basically what we're looking at here is, again, the two changes that we saw in the first solution. So the user changes the duration of activity A to be 10. What we then do is we add a node, which is a user action node, and record the changes that the user has done. So for example, here we record the key that the user has changed. So in this case, the duration. We record the new value that this key received, the property, and the timestamp. And now if the user wants to change the duration to 20 on this node, we just add another user action node. So now how could you go about saving this away now? So again, the user presses the save button, and you need to store this for a later comeback. What you could do is you just query on all the user action nodes, and go to your core database and just append these user action nodes to the respective node in the core data. So as we saw, activity A is part of the core data, just as all the other activities are as well. And you just take the nodes together with the edges and append it to the core database. There's one thing you have to take care of. So if that's a project that the user has already loaded and wants to resave, then there are already user action nodes available on your core database. So you would need to either merge these, so see whether there's already the same node available with that same edge to that same other node in your core database. Or probably the best thing to do is to just erase all the user action nodes from this one user or this one project and just put the new ones in. If you now want to load the graph again to the user, so the user loads the project again, you can just load the core data, so all the activities with the user actions of this one user, and apply all the user actions again to the nodes, and then you have a clean graph again. So here you see that we still have the duration property on the activity node, but we have also the information on the user action nodes. So this is like a running thought here, which you'll see again on the next slides as well. So applying those changes. So we copy the core data, which doesn't contain, of course, the changes that the user has done, together with all the user action nodes and their edges. So how would you do that? Have you thought about it? So do you have a backend where you use the Neo4j driver to access the nodes and then apply the changes? So to see, okay, here's duration 10, I'll put that onto the node. Or do you write a user-defined procedure for that? And I will answer this question at the end, or when I'm done with all the different scenarios that we have. So now you want to create a log. And probably you see that this is very easy now from this solution, because you just query for all the user action nodes that are in this user database now, and you sort them by timestamp, and then you have your log. So you know what the user changed at which time. Which is also quite nice about this solution is that if you want to do an analysis about what the user does, what the specific user does, for example, so does he change a lot on activity A, for example, or maybe does he change a lot on activity E, you could do that easily because you have all the nodes available. What you can also do is if you go to the core database, you already have, you of course have all the user actions of all users. So there you could also run an analysis. Maybe there's a specific node where every user changes the duration to 10 or something, or maybe there's a node where every user deletes this node in customizing his graph. So this is a nice feature when you're going with a solution. Of course, now looking back to the solution that we looked at before, the graph screenshot, you can still use the action on node with a graph screenshot. So you could just save this whole picture away again as a graph. But I think we all realize that this is not really a good solution because again, we have the duplicates and the loading and saving is not really nice. The downside of this is, of course, you get a lot of nodes and a lot of edges in your graph. So if every user action is one node and the node is connected to this action on node, then you have one edge and one user action, one action, one node for every user action. And if there's a lot of user actions, like 100,000, then you have 100,000 new nodes. What you could consider in modifying this approach a bit is that you say, okay, maybe if there's a user action which has the same key, then I kind of stack this. So I have only one user action node for a duration change. But then things get again more complicated with the log and with undoing things. So I wouldn't recommend this. The next solution that we envisioned is a bit similar, a bit different in some ways. So basically, again, we're looking at the duration change to 10 and to 20 of activity A. And here you have a user node or a project node, and the user changes the duration to 10 on activity A. So what you would do is then you just create an edge where the information of the change is written onto the edge. And again, if the user changes the duration to 20 on this activity node, then you have another edge from the user. This has the advantage that when you save away your graph, you just need to save away this one node. Of course, you have a lot of edges to save away, but this one node probably already exists in your database, and you just need to take care of the edges. If you look back on this action on edge, action on node solution, then there wasn't a reference to the user yet. So when saving away the action nodes with the edges to the core database, you need to provide a reference onto the node, which user has done that in order to be able to differentiate between the different user action nodes. And here it's a bit nicer because you have the information on the edge. What you then again do if you save away this project is a bit similar to the action on node, because again, you need to just take all these actions and save them into the database. But again, if you have already a user node there, because this user has already loaded this project once and resaves it now, you probably would delete all the old action edges from there and just put in the new ones. But already this is also a bit of fiddling around. Now the loading is very similar. So again, you load the latest knowledge graph with the specific one user node and all the edges that belong to it, and you apply the changes that are on the edges onto the activities. Again, have a thought. Would you do that from the Neo4j driver backend, or would you write a user-defined procedure for it? Again, creating a log is very easy here because you just query for all the action edges between the user node and any other node and sort them by timestamp, and you have your log. Also, the user action analysis is easy because you have the edges present. Here again, you could think of making this a bit shorter because, of course, this gives you exploding edges. So if you have 100,000 user changes, then you have 100,000 edges that are added. So what you could do is you could write all the user actions onto one edge. So if there are like two actions going to one activity, but probably you wouldn't save much. And now let's go to the fourth solution that we thought of. And yeah, this is a bit more complicated if you look at it the first time, but yeah, this is kind of our favorite. So here, again, we want to look at the duration change of activity A. And if the user changes now things, we change that on the activity node. And there's nothing other happening in the graph, but there's a user action object being generated in the backend. So where we just store the affected node, and again, the change key, the new value, and the timestamp. So these things are similar to the ones we have seen before. And if the user now changes the duration to 20, there's another user action. If you want to save away all this now, what we do is we serialize this into a JSON object and save it on the user action history node. So that's basically like a user node where we save all changes. And this is quite nice. Well, if you want to load the graph, then so if there's already user action history node available in that database for this project, then you just overwrite the changelog. So just delete that old changelog property and just write the new one in. So there's no fiddling with the graph so much, so you don't have to delete some edges or merge the graph together. And if you want to load it, you just need to look at this one single node, read that JSON from it, and apply the changes. And apply the changes, so I mean, put the properties onto the different nodes. Again, here, the question, do you do that using the Neo4j driver, or do you write a user-defined procedure? And the solution to that will come very quickly now. Now, what about the log? So we've seen with the action on edge and action on node that the log creation was really easy. But here it's not that easy. So you can't create a log from the graph itself. But what you can do is create it from the backend. And because you have all the user actions in the backend, you can then create the log from the backend and not from the database. If you want to do a user action analysis, this is also difficult because you don't have any information except for this long JSON in the user action history node about the user actions. But what you can then always do whenever you want to do an analysis like this, you can just go ahead and write a function that creates a action on node or action on edge graph for a single user or for all users together, and do this analysis. So this is for analyses that you do not regularly, so not every time someone logs into your application. If you want to do that from time to time, that's still viable. And now let's look at some code. So as I already said, this is kind of the favorite that we picked during the discussions that we had in our team. And I want to show some code now. So what I'm going to show now is two things. So this is going to be the how to apply the user actions using the Neo4j Java driver. And the next slide will be about how to apply the user actions using a user-defined procedure. And I hope you see the differences here, and I want to point them out. So if you want to apply this user action history to the graph, what do you need to do? So you first need to get the JSON. So you need to get this from the graph. Using the Neo4j driver, you just create a session and transaction and just match for this user action history node and return the changelog. Okay, now you need to convert this JSON that you got from the Neo4j database into a proper object. And so what I did here is I created a user action history object, which contains a list of user actions, and the user action, as you saw in the picture before, just contains the affected node ID, the changed action key, the new value, and the timestamp that isn't here. So now you want to apply all these user actions from the user action history to the graph. And what you can do is, again, just loop through all the user actions that are in this history and apply. So you first have to find the node in the database by ID, for example, where you then set this new property to the new value. And of course, you can do that a bit more smarter than here. So you could try to concatenate things. But however you do that, you will always have the problem of handling a very complex, or becomes more complex if you do it more cleverly, cipher query. So you deal with these literals here. And so a word of warning, this looks quite easy, but I wouldn't suggest you do that, because this will turn out into very high load on your computer, and your application will run very slowly. So let's look at the other solution on doing this as a user-defined procedure. So the user-defined procedures, this is something that you have to write in Java. And then if you compile this project, you get a jar file. And this jar file can be then put into your plugin folder of the graph database you're looking at. And then the functions and procedures that you coded, they're directly executed on the database itself. So here I have a procedure which receives a node, for example, as a parameter. So it receives the user action history node. You don't need to do this. The procedure itself could also go looking for the node, which is just one more additional step. So again, we have the three things we need to do. We need to get the JSON. Here we need to fetch all the nodes, or also look for the nodes from the database, and then apply everything. So my user action history object just looks the same as in the previous slide. Just for the conversion looks a bit different because I can get the string now directly from the node using the node functions like getProperty. What I then do is I fetch the graph and put it into a hash map so that I can quickly address the nodes. So I can get a node very quickly by ID without it taking long. And then the third thing is I apply the user actions, but this looks very different now. So this is not a Cypher query, which I use from a driver, but I can directly work on the nodes that I have in my ID to node map. So in my graph that I got, so this hash map, just get the node that is affected and just use the node function set property to set the new property and the new value. And this is really nice because you basically get rid of any strings. You don't have to write a cipher. And this is also really quick. And I want to show you how quick that is. So this is a very short comparison. We have here the number of user actions. So this is just something I tried out. And I have different lines here. So I have tried out like with 1,000 nodes, 10,000 nodes, and 100,000 nodes being in the Neo4j database. So the activity nodes in this case. And this is the number of user actions that I'm applying. And you see that with the user-defined procedures, it's all very quick. So even 100,000 user actions put onto 100,000 nodes is really quick. It's like around 10 seconds. But now look at this red line here. So here we have 1,000 nodes in the database, and with 100,000 user actions, this takes an enormous amount of time. And remember, like you see here, that this is the log scale axis. So this here is 10 seconds, but this here is already 5 minutes. So it takes you 5 minutes to apply all the changes to your database. And this is why you should never use the driver for such complex things. You should rather use the user-defined procedures. And now let's do a quick evaluation of what we've just seen. So I presented to you 4 different solutions to the modeling problem. The first, the graph screenshot, where it seems really easy at first. You just pack it up, put it away. But actually, this is really hard to handle in practice. It's not flexible. So if the knowledge graph grows, what do? You just have to then mix it up a bit. So this is really horrible. And also, if your code evolves, then you have these old saved projects where you have old properties and new properties are not available. So this is really a nightmare. If you want to do action on node, well, that produces a lot of nodes and a lot of edges, but you have quite a good visual of what you do. But this graph merging, so putting away the user actions to the core database once the user is done and wants to save, is a bit more challenging. The action on edge is quite similar to the action on node, of course. It does not produce that many nodes, so just the edges amount is the same. You already also have a good visual, and you have the same problem with the graph merging. And then I presented this 4th approach, the JSON serialization. That keeps the graph clean. You don't have that mess of edges and nodes. And also you have the better backend knowledge that you can, better backend logic that you can implement. This, however, might take a duplicate deserialization. So as you've seen, I need to deserialize the JSON in my user-defined procedure in order to apply the changes, but I also need to deserialize into the backend to get the backend logic, also for getting the logs and so on. So a very short summary about the 4 methods. So the graph screenshot is not really good. You should never use that, although it seems like a very good solution maybe in the beginning if you're starting. The action on node and action on edge are not really bad. They're okay. So if the number of user actions is comparably low and you want to execute a user action analysis continuously, then this is a good solution. And we're going with the JSON serialization. So you can put basically any number of user actions in. And it is really helpful if you have this more complex backend constructs that you need for making changes on done. And with that, I'm concluding my talk. So if you want to discuss a bit, I would really like to know whether you have come across this challenge as well. Maybe why or why not. Have you seen other things than just people querying the graph to look at things, to gain knowledge and to actually work with the graph? And maybe have you got other solutions for modeling the user actions? I would be very interested. So I'm going to stick around in the chat a bit to talk to you. And also you can contact me on LinkedIn. I had the small link at the very beginning of my slides. Thank you very much. And we'll definitely continue this journey.
Thanks, Elena. That was insightful. So unfortunately, we don't have any time for the questions. So there are a few, 3 ones to be more precise, but I think they take some time to answer.
All right, I will look into it and get back to the people.
We need to get the next speaker ready. So yeah, get a fresh cup of water or coffee or whatsoever. And we will see us in a few minutes with an OGM in Python, how to write an OGM in Python. Thanks a lot, Elena.
Thank you very much.
See you again.
Bye.